I guess the goal of the talk is that even if we're in an imperative language, that we don't have to necessarily stoop down to imperative levels, and we can bring functional constructs from other languages and still use them to a degree to make programming fun still. And just my journey of going through and learning functional and then having to go back to Python and the struggle and just writing libraries for myself, so it was enjoyable again. So we're going to get started, kind of dive right into it. So fairly usual imperative stuff you'd see, right? A lot of exceptions, checking a lot of stuff, not much reusability, lots of nested if-elses and try-catches and all that kind of stuff. There's probably like 2 or 3 places where probably like 5 exits for the function. Not much reusability, and you know, I think it's hard to figure out what's going on at a quick glance. So a little hard to digest, and I think if we had to add more stuff, it would just become more complicated. And to make sure that we don't break things just becomes harder, right? So it's got to be something more than this. After doing functional programming for probably like 3 or 4 years and looking at that code, it just kind of makes my head hurt. Especially after doing Scala and closure. So maybe we could write it like this instead and factor everything out and factor out the if-else statements and let different constructs actually do that for us. I think people are used to seeing patterns in code, but not seeing patterns in control statements. So I think if you do a lot of Scala and closure, you realize that you're not writing a lot of if-else statements anymore. There's other ways to flow data and iterate over things and whatnot. So we're doing the same kind of thing here, right? Like, all we want to do is figure out how you parse for empty, and we can compose that with a couple functions. Then we're going to parse for a value, and then we can use the either construct to do our control flow for us. And then we can Flatmap, and that kind of tells us that, hey, check length could possibly error, and then we're going to try to parse empty or parse the value afterwards. So the cool thing here is you can kind of focus on what's really happening rather than focus on the CRUD that we were looking at a second ago. So how to get here? Just quick talk about the various programming languages I've worked with. So started with C#, did a lot of C++, and then first into Python. And at this point, I already kind of felt like object-oriented programming kind of bit me pretty bad. And you know, changing the base class and adding functionality to stuff in the base class was, you know, something you're taught not to do. But when you don't know what you're actually the final product, it's hard not to mutate that stuff. And you realize that like when you start changing the base class, you could be breaking all sorts of things. And when you're trying to ship something and you have a deadline, that can be actually worse than better. So sometimes sharing code is not as good. So I moved to Python at that point, to a little Objective-C, Ruby and Java. So still a lot of imperative programming. Back to Python and then PHP. And after the PHP gig, I really was more interested in functional stuff and started learning Scala on the side. And Hacker News is your friend. So went on Hacker News jobs and got a Scala gig through that. Did that for 1.5 years, and after that did a closure gig and got that through Hacker News as well. So thank you, Hacker News. And then back to Python. So I think the interesting thing is I can't seem to get away from Python, and it's literally everywhere, right? Like every place I talk to, somebody's using Python for some part of their thing. So it's nice to be able to program in it, but the Python code I've seen is not to my satisfaction. So I think the 2 important things were the Scala gig and the closure gig, and that really changed the way I see programs, and I think it's like rewired my brain to just understand functional and see functional and not think in imperative ways anymore. And it's not about just step, 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 but more about, hey, we have data, we need to transform it, how we transform data from A to B, and that's actually what we're trying to do always, right? We're just trying to transform data. We're not necessarily trying to just do A, B, C, D. So Scala real quick, right? The amount of if-else statements I wrote in Scala were almost none. It was all about data flow, and I think you can read this pretty easily and see mostly what's going on, even if you haven't seen Scala before. And the constructs there like let you, if there's an error, we're just gonna throw a bad request if we have bad JSON, right? Start a DB session, build some queries, run the query, do the drop take, which is we're just paging pretty much, and then return a JSON object to the user that's calling us. So Scala taught me a lot about type classes and control flow, and then moving to Clojure was kind of the whole the opposite spectrum, right? Because Clojure is like, we don't care about types, right? Just drop all the types. We have like 3 or 4 primitives that are really cool, and we're just going to work with those primitives and make our lives super easy. And I think the best part is that once you realize that all the syntactic sugar I have to deal with in Scala, there's none of it anymore, right? There's a lot of parentheses, but there's no commas, there's no, all this other crud that's there goes away. So you can really focus on what matters. And I think the cool thing as well is functions really become first class. And I know other languages say they're first class, but they still have different forms. In Clojure, you just put fn in front of something, and it becomes a function. It's that easy. You can pretty much embed it anywhere. So writing functions in Clojure is as seamless as writing an expression, which really changes the way you implement stuff, right? And so I think one of the important things is too, so all the blue code is, all those functions are actually built in as part of the core Clojure library. So one thing they really like to do is the core Clojure library probably has around 100 or 150 functions that just are super useful that you can use. And you find that being able to use those functions and construct them in different ways just lets you do your job much more easier. Versus Python, where there's no way to check if something's empty in Python, right? You do length equals 0 every single time. And that could potentially fail because if you pass in the wrong thing into length that doesn't support length, it crashes, right? So new Python gig, I was asked to write a fixed length parser, and code already existed to do that, and it was all imperative code. Pretty scary at that point. 7 layers deep inheritance. People were adding feature flags to the base class because they had different parsers, and different parsers need to act differently. So they were supposed to reuse everything. So it's oh, but I need to do something just a little differently. So I'm going to add a flag in here. So when this is on, it's going to behave differently. And when it's off, it'll behave the same because no one really wanted to break anyone, and no one wanted to redo all the code as well, right? And then just super weak encapsulation. You don't know why the functionality that existed, why it was broken down the way it was, why the inheritance was in the layers it was. And so I was given, here's a new file format, use this system to parse it, and I was well, I need to do something a little differently as well. So what do? Do I just go in there and, add a new feature flag that, lets me do something very differently? And I was I just can't do that. After functional programming for so long, I'm maybe this is a good way to rewrite everything, and not really rewrite it, but just show my colleagues that we can still reuse code using functional techniques, and we can use composability to put these things together. And then we can reuse a bunch of code, and we can keep the business logic for those parsers within the parsers themselves. And we can just use the functions differently. We can just compose them differently to do what we want. So we get the benefit of both worlds without having to have this complex hierarchies of systems that were created. So I kind of end up with this. It's pretty similar to the first function I showed. I think the big difference is that we pass in validator and parser. So now it's a more generic thing, right? So we're going to do the same thing, right? We're going to check the length. If it's spaces, and that was kind of like the special thing I had to do for my parser that other parsers didn't have. If it's spaces, we're going to return none, which is valid. Otherwise, we're going to validate the data, return an error if it's bad, and then try to parse it and return that parsed data. So the nice thing is now we can pass in functions, totally reuse this. But looking at it, you still have all these if-else blocks and a try-catch, which I'm just not used to writing anymore, especially after doing closure in Scala for so long. So I was thinking to myself, I wish there was a way I could use eithers or tries or these other constructs to do the control flow for me. So went online. There's definitely stuff that existed out there. So I think they were more on the Haskell side of things, where I was used to more the functionality that the Scala implementations gave me. So I think like PyFN only had an option. PyMonad and O/ did have an either, but only had like Flatmap and map, and maybe another function, and that's it. And I wanted like swap and get or else and fold and all this other stuff that the Scala implementations gave me. And I thought that because Scala is also from the half world of we want to be functional, but we're an object-oriented world, and I think that fits more in the Python kind of thing as well. I was like, maybe I'll just implement my own, right? So I wrote a library called PyFNs. The name's kind of weird, but getting Python library names nowadays are almost impossible, so you gotta get what you can. So I kind of implemented a few things. Did a biased either from Scalaz, because I think the original implementation from Scala was normal either, so like it wasn't the greatest thing for error control. Did a try, figured out how to do clean do notation to join stuff together, and just brought some of the like core closure functions over as well, like isEmpty and butlast and stuff like that. So why either, right? So like all those if-else statements, if we can abstract that all out and put it inside a container, we don't have to look at it anymore, right? And we just know how a container works, and we can use that system instead. So all we're doing is we're going to wrap a value, right? And we're going to say that if it's a left, we're going to represent a failure, and we're just going to stop computation, right? So no matter what you ask me to do, I'm just going to keep on returning that left. And the same thing, so the right's the opposite. That's going to be a success. And as we ask for computations on a success, we're going to just keep on continuing to do those computations. So it's pretty simple, right? Like I just went online, went to Scalaz's GitHub, looked at the code. I'm like, I can literally copy and paste this across to be Python, right? If you get rid of all the type signatures that we don't have in Python, it's still both defs. Instead of a match, we're doing reflection. And we're doing the same thing, right? If it's a left, we're going to just return the left that we have. And in Scala, you just have to do some coercion to change the type to a D from a B or whatever, but we can ignore that part. And then if it's a right, we're going to run the function on the value that we're containing, and then we're going to wrap it in a successful value again. And then Flatmap's pretty similar, right? The only difference now is we're going to expect G to return an either instead of returning a normal value. And again, the code kind of just maps over really well. So I didn't map over everything. Some of the stuff is a little more complex and needs, like, I think in certain places having a type system helps to do things. So I tried to only bring things that were kind of useful and didn't need the extra type information. So let's see something that without an either, right? So imagine we have a function that's trying to get half of a palindrome. So we're going to do a couple checks on it. We're going to check the length. We're going to make sure it's all lowercase alphabets, and then we're going to make sure it's actually a palindrome. And if any of those cases are bad, we're going to raise an exception and say that we have an error. Otherwise, we're going to get half the palindrome and return that from the function, right? So a nicer way to do that is with either, right? We can use Flatmap now and say, hey, we're going to wrap this in a right, which is our data is correct. We can see Flatmap as, hey, check length is actually maybe going to return an error or not. Check lower alpha was going to do the same thing. Check palin is going to do the same thing. So we have 3 things we're going to check, and then if all those things pass, we're actually going to just run get half, which is going to return half the value. So when we return on this function, there's one return, and we may return an either successful value, or we may return a failure value. So a lot of the code is missing, but really, like, it's doing exactly that, right? Like, check length, if it's not empty, we're gonna return a right or an error, right? And check lower is the same thing. I think the cool thing now is that you're being more functional. You're breaking stuff up into a way that you can think about what you want to think about at the time you want to think about it, and you can dive as deep as you want to into the information without having it to digest it all at once, which is actually kind of nice. And it just makes your reasoning a little easier. When I read that function, the lower part that I showed initially is really what you care about, right? And if you want to change something, it's much easier to look at those 5 lines of code and add or remove something than look at those nested if blocks that we had before. So on to try. So try is pretty similar. The only difference now is that we're going to try to abstract out the try catch. And we can use Python's class instantiation to kind of allow that to happen. So we can construct a try, and so we wrap it in a try catch, and if it fails, we're going to wrap the value, and it's the same thing, right? We're just wrapping one single value, and that's going to be a failure and an exception. And if it's successful, we're just going to run the function and it's going to stick that value in there. So that the cascading of the failures is exactly the same. And the stuff down here is mainly so because we're inheriting from try, we don't want to take this new implementation. We just want to like return ourselves. So there's nothing really fancy going down here. But it's cool that Python lets you actually get away with doing this kind of stuff. So my first implementation kind of looked like this, which is kind of gross because I guess it's how you look at it, right? Like, so this is Scala. And I think when you first look at it, you're like, well, if you're doing value to int, how does this actually work? And so the kind of annoying thing about Scala sometimes is there's a lot of syntactic sugar. So if you have a single statement, you actually don't need braces to represent a block. So what's actually going down here is you're passing this in as a value that's as a construct that's being run inside of try when it gets passed in, even though it doesn't look like that. So you have to do that same kind of thing on the Python side, right? So we have to wrap in a lambda, which makes an anonymous function. We pass that in, then we run it. But it's really annoying to look at that, right? Like, I don't want to have to always run a lambda and then pass that in and then run the function. So I was like, a lot of Python actually does this, where we can pass in the integer, which is the function, and then pass in the value. So we can do args and kargs and pass all that stuff in, and then we'll just pretty much run the function we pass in with the values that we pass in as well. So it's a little easier to read, and we don't have to wrap it in lambdas anymore, which is kind of nice. So an example of without try, right? So we're getting some user input. We're getting a dividend. We're going to read that from the user, and then if anything fails, we're just going to default to 1. Then we read the divisor and do the same thing. If something breaks, we're going to just default that to 1. And then we're just going to divide that value and return it. And again, if the divisor is 0, we're going to throw another exception, and we want to default that to 0. So it'd be nice if we could pattern match all of the try catches out and extract that away, and not have to care about that so much, right? Like writing if else's and try catches are just become annoying after a while if you've done functional programming. So maybe a nicer way to do it is this. Have a function that always returns 1, which is going to be our default value. And then we can actually compose int and read line together. So we can read from an input and convert that into an integer. And then we do the same thing, right? We're going to wrap in a try and say, hey, let's try to read a divisor, try to read a dividend. And if either of those fail, we're just going to default that to 1. And then we're going to lift into the look inside there. Well, like these both may be failures. So we're going to say, hey, if this is not a failure and this is not a failure, then let's try to divide by 0. And the cool thing is that once you're inside of a try, it's going to catch any exceptions thrown as well. So it's totally safe to do this inside of a map. And then at the very end, we can just say, hey, but if this is a bad value, we don't really care what happened, just return a 0, right? So it's much easier to reason about this code. We don't have 3 layers of try catches anymore. We don't have to write try catch, and we can just treat failures as a value instead of throwing exceptions everywhere, which is kind of nice. So I think the hard part now is if we have like a bunch of these, so a bunch of tries or a bunch of either's, how do we put them together, right? Like flat mapping and flat mapping and flat mapping, it's super ugly after a while. So my first implementation is like what you saw before in the try, right? Flat map, flat map, flat map, and I think if like maybe with a couple it's okay, but as you get more and more, it becomes really hairy to read. So I was like, maybe there's a better way to do this, right? So what you're actually trying to do is you're taking a bunch of values and you're trying to reduce them into one value, which is pretty much a folder reduce, right? So I'm like, how can I use that to make this a little cleaner? So my next implementation was implementing a partial, where I can say, hey, we're going to start with a function that I want to run, and then if these values are correct and they're not failures, we're going to map into them and apply the partial on the function. So the first thing you're going to do is you're going to take make parser, and if this is a good value of name, we're going to apply the partial to make parser, and we're going to do that same thing 3 times. If there's an error, it's just going to return the error. But if there's not an error, then it'll return a function with all these already set in there. And then unfortunately, then we have to map and execute the function to actually get the value out of it. So it's still ugly. If someone saw this and weren't functional and didn't really know what was going on, they'd still be like, what are you doing there? Which is kind of the opposite of what I want with the library. So talking to a friend of mine, he was like, why don't you use the for construct somehow that's built into Python and use that to your advantage to maybe try to implement something like this. So my first pass was like, you're right, you know, like there's a next that I can implement on the either's and the tries, and so we can kind of lift out of there, right? So we can say, if it's a successful value, we're going to return that value, which is only one value you have to return, and if it's a bad value and it's a failure, we're going to actually throw, and then we can just catch that. So it's kind of nice now. Like this is actually much easier to read than what we had before. This kind of looks more like Haskell's do notation, looks more like Scala's do notation. The only problem now is that list comprehension executes immediately, so we have to put try catch around it in place, which kind of sucks, right? How do we pass this into a function and make it look nicer? Like I don't want to have to write try catches everywhere. So the cool thing in Python is we actually can do that, right? We can use a generator. So we can use generator comprehension instead. So now we have a do where we can cleanly lift out. So if these are all valid and successes, we'll pass all those values into make parser. and that will return a success. And if it's a failure, it's going to return the failure, which is kind of cool now, right? It's much easier to read this code. It's pretty succinct. And I think the only problem now is you'll notice the either in front of the do. How do we know what value to create when it's successful? When it's a failure, it's actually pretty easy, right? Because we have the failure that we just caught. When it's successful, we don't actually know what to reconstruct anymore. So there's two routes I could have gone. And so I initially was like, hey, maybe I can have a global do, and I'll introspect using reflection into all the types that are inside that generator and figure out like what you're actually trying to do. And it's totally possible, and there's code out there that does that kind of stuff, but like it just gets super hairy. And if there's function inside of functions, like how deep do you want to go to figure that out? And is it really worth it going down that rabbit hole? So I decided like it's just easier to make a static member or function on an either and a do. So now I know what your intent is, right? I can just be like, oh, the return value is going to be either, so I'm going to wrap it in success. The return value is going to be a try, so I'm going to, or wrap it in a write or a success, right? So I'm going to quickly talk about some of the closure stuff. So the stuff on the left is, code that I've seen in Python a lot, all over the place, and you just type it over and over again. And I think one of the big problems is like, if you don't have the beginning part, like collection is none, if you pass in none to length, it's going to explode, right? And that's a super easy mistake you make. You have a function that returns a collection. You assume it's going to be a collection, and so you just check the length, and if it's empty, you do something, and if it's not empty, you do something else. But that can actually fail if it returns a none because you can't do lengths on none, right? And so the cool thing about closure is it defines a lot of this stuff for you. So we can pretty much implement an isEmpty that does this for us, right? Like we don't have to write this code over and over and over again. We can just be like, hey, it's isEmpty, and we can be guaranteed this is not going to blow up because we're going to check if it's none first, and then we're going to check the length afterwards. Of course, if it's a random type and you do that with, that doesn't implement the length, it's still going to fail, but we're going to assume that you're going to pass in a collection to isEmpty to, be smart about that part. The same thing with first. Again, you have to make sure that it's not none because you can't index into none. And then you're going to make sure that the collection is not empty as well. And you're going to do something if both these things are false. And then finally, you're going to be like, okay, let me get the first element. So the nice thing is like, why not just have a first that does this for us? And then we don't have to worry about writing this huge block everywhere and concentrating on the stuff that's really annoying to concentrate on. So I brought over, just a few things that I ran to all the time, just like first, second, last, isEmpty, rest, identity. So it was kind of like when I saw a problem that I was like, oh, in Clojure I did this way, and I remember using the libraries in the core. I was like, let's just port that over. And it's fairly simple to do a lot of that stuff. So there's probably only like 10 or 15 right now in there. But that's because I was like, hey, I need this, so let's bring it over. So I think the whole goal of this is just to make my life in Python easier and more fun than it was when I didn't have these constructs. And like working in Scala and Clojure just taught me how to do things in a certain way. So when I realized that like I didn't have these tools anymore, like I just didn't want to write old school Python anymore. So it's kind of nice, right? Like you can actually write nicer code now and more succinct code than like when I write code, I know it's not going to break and just be more aware of what's going on, especially with errors and stuff. So some of the stuff that I want to do, add more is like add an option, add observables, transducers, which is kind of a concept from stream processing in Clojure, and just port over more Clojure core stuff as well. So a link to the library. and then it's on pip. So one of the first things I do is, pull that stuff in and use it in the new scripts I write. So, yeah. Any questions?
So Python's not a performance language anyway. But did you notice any performance issues?
Yeah, my friend asked me that, and I was like, I just don't care. If you're writing Python expecting performance, you're in the wrong language.
So you're not noticing anything, it's not fun.
Yeah, and I think like I/O and all that stuff is going to take way more time than function processing and stuff. So like if you care about performance, you're going to drop down to C or many other things. I think it's more important to write correct code than write performant Python code. I think originally Python was used to glue things together, and then it just got a hand. And now people are building entire infrastructures with it, which I think is just like wrong to begin with. But to each their own. So.
Well, that's the only statement you said before that disagrees with.
I mean, I think it's like profile it and find your weak points and benchmark it, and then optimize afterwards, right? Just make sure your code's correct first, and then you have tests, and then you can change it, and then you're not breaking anything, rather than do the opposite, right? Like, and I get it, right? Like, a lot of this is probably much slower than writing all this stuff straight, but then if you have all these programmers reading it, and how many errors are you going to get when people are changing it and all that kind of stuff. So like, where are you spending the money, right? On stuff breaking. So the last place I was at, they literally wasted, they spent on, they lost $1 million because their Python was incorrect, and they didn't notice for X amount of time, because it was a bug that happened, and it was like the way it was translating dollars to cents and stuff. So yeah.
No, I was just curious. I mean, if you ran it and didn't notice any performance issue outside of what you're normally noticing Python, then obviously it's...
Yeah.
I'm noticing that you built all of these based on 2.7.
Yeah.
Do you have a 3.0 version?
I don't believe in types in Python, man. I think they should just not call 3.0 Python personally. I only like 2.7. I don't believe in the mentality that they did it wrong and they add types. Use Python for what it's meant to be used for, and I think it's a scripting language, and leave it at that. So I'm not a fan for 3.0, and that's one of the reasons that I only did it for 2.7. And if you look at O/, all that stuff is all type-based and whatnot. And that was one of the reasons I didn't use that as well, right? I like duck typing when I'm in Python, right? I want to use the advantage of Python when I'm in Python. I don't want to make Python another language. If I want to do that, I'll just use another language, right? I'll just not use Python anymore. So I think you should probably run in 3.0. I don't know, you can try it, but I have not tried it, yeah. There's nothing actually crazy in there, so it should probably compile. I don't know much about what they changed in 3.0, so.
All right, thank you.
Yeah.
What kind of reaction did you get from the other people looking at your code, or did you compare them?
They were super pissed. It was probably 200 engineers. The entire infrastructure was written in Python. When the lead engineer, which was, it was San Francisco, right? So your leads are 4 years out of college without any experience, but they're leads and seniors. He was like, this is not Pythonic code, blah, blah, blah.
Was that the argument?
Yeah, pretty much. And I was like, there's ITER tools, there's func tools. Python is in the middle, I think, of that. And I think it's easier to gear toward, list comprehension that's totally functional, right? All these iteration stuff they have built in, there's so much functional stuff in there. People just want to look away from that and be like, no, it's imperative, right? And I think when you're on a school, everyone teaches you imperative, so you're writing imperative code, and that's what they're used to. And I think they were just so shocked that you could do this differently that And I think he wrote all the like 7 layers deep of inheritance too. So he was personally offended of what happened, right? And so in the end, they admitted it, and I did open source this. I wrote that when I was there. I did open source it. I don't work for them anymore because I think just like no one was willing to change their mindset, and I was like, I can't work here if you guys don't want to grow and be different people, right? Like, and I brought up the same argument, right? Like, React is all like, it's all functional concepts that made it so popular, right? And you make less mistakes. And like Elm and Clojure and Scala, all these things are becoming popular. There's a reason for that, right? It's not just like a fad. Like, people are writing better code and making less mistakes because they're thinking a different way. And they just didn't want to hear that, so yeah.
Question for you, just realistically. Thank you for the talk and thank you for the work here. But I remember having some conversations. So I have some similar situations with you. I've been very happily writing functional code in Scala, but due to the data science world, modeling and using stuff that's just heavily in Python, at least for now, it's just stuff's being done in Python, and I've even been like, for God's sake, at least I did 3.6 to get hyped back and things like this. But I was joking and saying, my friends, like, the solution to getting functional Python code is to not write Python code. And so I'm just saying, what's your thought about here? Like, do you think Python can be pushed further to be more functional, or is it just its own thing? It's going to be Pythonic, so give up. Like, I mean, what that guy said, he may be unwise, but he may be right.
So I think the problem is that, like, because Python's so easy to get into, right? So you have so many inexperienced, like, there's a reason it's a data science language, right? Because data scientists don't know anything about programming.
Yes.
They're data scientists, and they want to hack ugly code. They don't want to learn to code. They want to glue stuff together, and the only way that they're thinking is imperatively step, and that's what they do. And that's not how they use it, right? So that's not going to change. And I think, like, I was in the VFX industry for a long time. It was all Python. It was all trash. You have artists writing code, but they don't care, right? They're like, I need to do step A, B, C, and D. I'm going to write the entire pipeline in Python. And then you look at the code and you're like, this is like a horrible mess. Like, guys aren't coding, right? You're just like gluing stuff together. But I think it's been taken out of context where like when you hear of Lua, like, you're like, oh, it's a scripting language, right? Like, to me, Python's should be the same thing, right? It's a scripting language that glues a bunch of stuff together. And that's the best use for it. It's like, if you're creating gigantic infrastructures for it, like, yeah, you're like, you're stepping on glass, so, and walking in the fire. So, like, I don't think that's going to change personally. I mean, I wrote this because I got tired of writing the bad Python, and I'm just like, I wrote this for myself, and I was like, I don't care, right? Like, you write code how you want to write it, but I'm going to go home, and like Paul said, I'm going to go pet my cat, right? Like, I know my stuff works, because when I look at it, I'm more confident that I'm writing good code. If you want to write bad code, but I'm not going to be responsible for that, right? So. Cool. Thanks, guys. Appreciate it.